Oh, that was quick start, huh? All right, class, I can see the red recording button and has started recording. And please be with me all the time. I know you will. And if you do have question, put it in the chat room and keep your microphone muted all the time, not unless okay, you need to when you want to say something related to the lesson, to the experiment, to the cooking demonstration that I'm going to show you because in this particular activity, as mentioned before the recording started, that in the process of cooking, which is science, that's why this is, let me look, pick up the logo, the Science Kitchen. Mhm. Science is practically everything we do, including in the kitchen. Open the fridge. I'm pretty sure there's science happening, especially if there is some food that has been decomposing. Open that. Like for instance, milk that is has expired. Check the expiration date of milk in the fridge. Make certain it's still fresh. Otherwise, real science is taking place. Any rate. So in this party, oh, Kevin left the meeting. Straight away. Kevin, please return. I'm pretty sure it's a technical problem. Once again, as I proceed in the process of cooking, which is a chemical change, you're going to identify other changes such as physical that can be involved in the process. Because in this particular cooking demonstration in a science class, there will be several steps that I will be taking into account in order to come up with the dish. Of course, you are going to identify the chemical change. And like what we did yesterday in our experiment on slime, we're looking for evidence of change. All right. So I'm ready. I got the hot plate here. It's not hot yet. I don't know how to turn it on to begin it, but the rest of the ingredients I need, like in a science experiment, you gotta have the materials. In cooking, you gotta have the ingredients. All right. So I do have the oil. I showed this to you. Needed. And somebody already told me that there is a salt. Okay. Salt to taste. This is Himalayan pink salt. It's also a salt. But Himalayan pink salt is a bit more nutritious. There is an extra nutrients in a pink salt. So therefore, white salt, pink salt versus I will go for a Himalayan pink salt. Kind of pretty pricey, but there is an extra nutrients, but it's still a salt. This is mostly found in Pakistan. All right, so that's why it's a bit expensive, but it's pink. That's called Himalayan pink salt. All right, and other things I need. Since I am going to make a sandwich, I need to have the bread. I have the bread here. I have some veggies, tomatoes, and I do have the egg. Right, first of all, let me start first with some cuttings involved. Right, I'm going to focus the camera, okay, on the things that I am doing, and your responsibility is that respond in the chat each time I ask you if what I am doing shows physical or chemical change. We can simply put physical or chemical. By the way, are you still with me? Type in the chat. Yes, please. I want to see more names there. Yes, be with me all the time. All right, once again, if you are lagging out because of technical problem, please return. All right, start with the cutting first. Okay, I do have a plate. Can you focus? So, in period 2 class, I did a cooking, so I saved half of the tomato. Okay. I said half of the tomatoes. This is a fresh. I have a tomato, so I saved the half for our class, and it was in fridge a while ago, so it's fresh. So I need to slice to cut the tomato into small pieces. All right. What did I do? Is this cutting? Is cutting a physical or a chemical change? Please tell me now in the chat room. Is cutting tomatoes physical or chemical? Yes, correct. People who have responded, I know you are with me. If you haven't, please put the word physical change. In other words, tomato, unless it is put on the pan and mixed with other ingredients and start turning mushy and changing in chemical composition because of additional substances, simply cutting and slicing is a physical change. Just like a chopping wood as compared to burning wood. All right, next step. Since this is an egg sandwich, I need to crack the egg. So I'm going to say the sliced tomatoes. This is not on yet. Okay, the sliced tomatoes. The next step would be okay, the sliced tomatoes is the fresh egg. Okay, so now in an egg, there are two parts. We have the yellow or the yolk and the white or the albumin. I want to separate one from the other by using a strainer. Of course, I need to crack the shell. Cracking the shell by hitting it is a physical change. Right? When I crack the egg, the shell is simply a physical change. So I want to separate the yolk from the white or the albumin. Okay, cracking the shell. There you go. That's physical. I will save the shell for the next experiment. Okay. Now, the yolk and the white. Tell me, separating the yolk from the white, separation of the yolk and the white, is it a physical or a chemical change? Type in the chat. When I separate the yolk and the white, is it physical or chemical? Waiting, waiting. Yes! Correct, Maria. It's only physical. I just want to separate them. What I want to do is to make sandwich out of the white and use the yolk for a different purpose. That is say, but I will not discard this. I'm going to save it together with the other egg I used in the morning. So in other words, there's two physical changes. When I crack the egg shell, that's one, and when I separate the yolk, which is the yellow or the red, pretty much yellow, and the egg white. Want to save the yolk. I don't want to throw it away. It's still food. And I'll mix it together with the other egg from period 2 this morning. So I still have the white here. I want the white for the sandwich. Okay, my hands are clean though. And this will be cooked anyway. There you go. Perfect. Okay, now save the yolk, cover it, and I will put it in the fridge to save its life. Okay, clean the hands with the towel. By the way, are you still with me? Type in the chat. Are you still with me? Oh, lovely. Woo. Each time I see yes, life goes on. All right, now I do have plainly the egg white separated from the egg yolk. Next step. All right, next step. Now, so far we've identified physical changes only, okay, including the slicing of tomatoes, the cracking of the shell, the separation of the yolk from the white of the egg. So this, I'll set it aside for the time being for later use. Finally, the cooking. So of course, in cooking, I want to make certain that I had everything already. What's the sandwich? All right, we need to have a pan, and then I'm going to turn turn off the heat now. Okay, don't need that anymore. Turn off the heat, and cooking takes place when heat is added. When there is no heat involved, it's not cooking. Like you're making a salad, it's not cooking because there's no heat involved. So heat added facilitate or makes cooking time faster, isn't it? The higher the heat, the faster the food will be cooked. Let me see. Ah, it's not totally plugged in. Hold on. That's the reason why it's not turning. Let me hold on, class. Huh? Okay. There you go. I'm echoing. Do you hear it? Do you hear me? There's an echo? Hold on, what's going on? Hold on, let me fix the audio. Can you hear me, Chris? I have two mic. Hold on. I think I do. Wait. No. Can you hear me now? It's better? Ah, yes. Oh, you know why? What happened? Remember I put a cover on that's on the like all this on the keyboard, accidentally got pressed. Sorry for that. All right, another technical problem. All right, now, yes, the stove is on already. So the higher the heat, the faster the cooking process. But it depends on the dish that you want to make, huh? It doesn't mean that you have to turn it to 10. But in this case, I want to turn it to 10. So here you will see, I just turned on the hot plate. I don't need the stir. I need the heat. So we're gonna put it to 10. Alrighty, lovely. Okay, right, boss. I hope you will not get too hungry. Anyway, lunch is right after. I hope you're here so I can share with you the dish. Right, really, I do with my students only if they want it. Okay. Remember, in this part of our cooking in science demonstration, you will continue identifying changes. Okay, so this time is the actual cooking process. So as I can touch. It's heating up now. All right, I will not touch this again later because I have a rubber gloves. It's sticking. All right, I need please watch very carefully. So a canola oil, a non-stick oil. Oh, yeah, lovely. Okay, you need to make certain this is covered. Perfect. Lovely. Woo! Oil. This is canola oil, non-stick. It's zero. It says 0 calories, so it doesn't bother me at all. Okay. So let's wait for a few seconds. You see? Let's see. I need my. Let's see. All right. I need you to really focus your attention. What do you see? What do you see coming up from the pond? Do you see steam? Do you see steam? Oh, yeah. Now you see a physical change taking place. It looks like it's ready for frying out. Lovely. Okay. Now it is hot. This is the egg white. Everybody, you're looking. Don't get too hungry. Okay, so let's see. Let's wait for a foil and then a bit of a salt, pink salt. There we go. Not too much of a salt. All right, let's wait for a bit. Okay, what's going on now? Is it starting to cook? Yes, it is cooking, Brianna said. It is smoking. It is cooking. Let me see. Yeah, it is full blast. Okay. Now, in a little while, I need to check every now and then. Otherwise, it will be a burnt egg. Oh, I can see that. Now you can see that there has been a transformation. Salt has been added, and this is no longer the original liquid egg. Okay. Ooh. This is now the almost cooked egg. Lovely. Okay. Perfect. Now, cooking egg is a quick process. Let me turn this off quickly. All right. Now, tell me what? Is this a physical or a chemical change? Physical or chemical change? Yeah, it is a chemical change. This is no longer the original liquid egg white that was originally covered with shell, and because of the heat, it changed into a different form of egg, and it's a fried up. Okay, I just turned off the stove. Since I am making an egg sandwich, I want the sandwich a bit toasty. All right, let me set this aside. The sandwich. Okay, let me put the egg right here. We need that egg here. Pretty cool, huh? Are you getting hungrier? Okay, are you getting hungrier? Nope. Why? Did you eat a lot this morning? Or maybe are you getting hungry? All right, I got the egg here settled. Since I would love to toast the bread. Okay, where's the bread? Bread's right here. Okay, I'm going to toast the bread. Tell me, toasting bread to the point you see the block. Okay, result. I have ate something. Oh, you haven't ate something yet, huh? Carlos, okay, so I want to toast the bread. Toast the bread on the pan. Tell me if this is a physical. Wait till I flip it. Is this a physical or a chemical change? When I toast the bread, see the black one, toasting. Is this a physical? You see there's a change in the color. Is this a physical or a chemical change? Think of the wood burning. Is it physical or a chemical change? Tell me. When you see the black, it's like a wood burning. When a wood burning, yeah, it's a chemical. So if I over toast it, it will change into like a charcoal. But it's not a charcoal. it's a burnt bread. I don't think it tastes so good. So what I want the bread is just warm and a bit crunchy. Heat it a little bit more. So here there is a chemical change involved. But simply warming it up to the point that it will not turn black is only physical in nature. Right? The bread is crusty and warm. Now, next step, to assemble the sandwich. Okay, assemble the sandwich. Lovely. Okay, tell me. I want to slice the bread. Slicing the bread, is this physical or chemical change? Slicing the bread, physical or chemical change? Physical, correct. So, in the bread, I want fresh. Can somebody tell me what is this? I want a lettuce. What about if I cut the lettuce into two? Is this physical or chemical? Cutting it in physical. So the egg here, oh lovely, which was a result of a chemical. My hands are clean. And slices of tomatoes. And slices of lettuce. And to top it off, press it a bit. Okay, lovely. The sandwich. All right. So it's a combination of physical and chemical change. All right. Tell me, did we see the process in cooking involving physical and chemical changes? Yes. That is a cooking per se, cooking itself, there is science involved. As I mentioned a while ago, when you open your fridge, there may be other things there that you think, oh, there's some science going on here. Freezing the water is science. All right? Saving the food to avoid expiration sooner because it's chiller, it's colder. Like you put the milk in the fridge, it lasts longer. It's science. On the other hand, if you put the milk just on the table and it's warm, sunny day, the expiration date will not be good anymore because it may start decomposing sooner than the expiration date. All right. So how are we doing so far? Have we accomplished our goal? Remember, our goal in this cooking demonstration is to identify the physical and chemical changes. Have we accomplished the goal? Yes, we did. And I hope you learned something from this demonstration that science is always part of life. Lastly, when you start cutting this using your teeth, it's physical. But when you start swallowing it and your body start digesting the food, then of course you know that in our bell word today, food digestion is chemical change. In other words, our body is primarily made up of series of chemical changes, and that causes us to grow. All right? Are we clear so far? Answer me by telling me your level of understanding, piece of 5. I know it so well. 4, I'm good. I understand it. 3, I do have a question or questions. 2, I am a bit confused. And 1, oh, sorry, teacher, I did not understand. I'm lagging off. I wasn't paying attention. All right, please tell me your response. I'm looking at names of the students. Oh, there's several top fives now. Excellent. Please make certain you have your name in the chat room. So, sharing with me your understanding about our lesson using the process of cooking. Let me find out who they are and what's their level. So I'm scrolling. I'm not going to call names, but if you haven't, please put your level of understanding in the chat room. I'm still missing a few students. Please make certain that you get involved now. All right. Uh, Next few steps. Thank you, Brianna. You're going to spend the next 4 minutes in looking and watching at a short video clip about the lesson. You will see this in a different manner. You may see extra additional example, but this is all about cooking and science. It is in the Google Classroom, week number 5, but I'm going to put it in the comment box for easy access. Oh, Cesar left the meeting. Hopefully, it's just a disconnection. And please watch this. And right after we will have an exit ticket. Time wise, good enough to finish the video viewing. Remember, huh? Listening may not allow us to remember, especially if it is way excessive. But we combine it with watching and listening, then we will be able to remember. More so if you start cooking, you understand. All right, let me just finish the recording.